Well, I can control the motor.
I'm sorry, Greg. Your metaphor word to say otherwise.
Oh,
Strawberry. Everybody said it was nothing.
all right. Hello everybody on the Zooms. We'll get going. We got 3 presentations tonight. Jim is going to bore us to death with batteries. Scott's going to entertain us with all the various ways to run the $25,000 HVAC system. And I, of course, have the only entertainment to be had. Learning about drywall. It's kind of like watching paint dry, only it's more plaster related. So anyway, I will share my fancy pictures here. I actually have a 3-per. I figured as long as I've got the crowd here, you might as well take advantage of it. So, hey, I needed that to get up on top of the shelf there. This was my prop here to get out. This is definitely OSHA training. Let me make sure. Yep, I got sound with the video shared. Okay, so I didn't bother dragging it over here, but this thing down here on the table or on the ground is a paint sprayer that we bought. It is a really big paint sprayer. It's like 2.5 horsepower, supposedly. It powered up 120 volts, but I know it sucks down 20 amps, so it actually is eating a lot of juice. And we needed this because we're painting this fire spray. And so this is, I have 3 things that I'll sort of talk about. One is this process of painting on this intumescent coating. So it's well named called Flame Off. I couldn't find the Flame On paint. I could only find the Flame Off paint. So anyway, this stuff is the fancy paint. So it's called fire barrier paint. A normal bucket, this bucket's basically empty. A normal bucket of this is like really heavy. It's super dense. The best way to think of it is the snakes and sparkler snakes for fireworks in a barrel of paint. So the idea is you paint this stuff on, and then if there's a fire, this stuff builds a coating and it blocks the fire from heating whatever's underneath.
Well, like acid?
It basically chars out.
We do a demonstration?
Yeah, I have a video. Better than a demonstration. Since I've had it smells bad. So the reason we had to do this is there's a beam in the stairwell in the back, and the beam in the stairwell in the back is supposed to be clad with 2 layers of 5/8 drywall. So it add 1.25 inches to the outside of the beam plus 1 inch of offset. There's like these clips that go on there. And the issue is we don't have 2.25 inches worth of headroom. We would be under headroom in order for that to work out, which means we would have to like re-engineer the whole staircase and take up more space, and it's a whole big mess. So we don't want to do that. So as a result, I'd figure out a way to fire clad the beam without changing the headroom. And so in this case, this coating is like 60 thousandths of an inch thick, and it does the same thing as 1.25 inches worth of drywall, according to UL testing. So long story short, I am spraying this. Also, we had an exposed piece of steel in the ceiling in the wood shop, and rather than trying to apply drywall to it, I just decided, since I got to paint the beam anyways, you got to buy this stuff in 5-gallon buckets. Might as well just paint a bunch of stuff. So, I have a video. I'll let the video do the talking.
All right, we are spraying a Flame Off intumescent fire barrier coating, which goes on the steel up here in the wood shop. So we got our steel beam. This is coat number 3 of 3. So we're nearly done. So we got a big airless painter here, and we can go over here. And we should probably be a professional painter, but the idea, we're about 1 foot away, and we can hose down a coat of paint, and then we're building up to be about 30 thousandths of an inch thick. Using a fancy gauge here, this guy. This is a wet film thickness gauge. So we put this up here, and we see which of the dots are touching, and that tells us how thick our coating is, which right now we're about 20 thou, we need to be about 30 thou, so we got a ways to go. All right, we are.
So, essentially, oh Jesus, yes.
I already have like 4 questions.
Take it away. What's one of 4 questions?
Did you just have a pocket full of those things, or did you wipe that paint all over yourself?
Oh, you wipe it off on yourself. Oh, I'm already coated. Yeah, that's where it's way beyond question as to how much paint.
Don't like this myself.
Yeah, fireproof pants.
Yes, I do have fireproof pants.
I'm gonna in my very near future need to paint a bunch of intumescent paint.
What do you have? What do you have that needs paint?
Spray foam with decorative wallboard on top. It's not
Oh, nice. Okay.
right. So, and the guy, one of the things the guy told me was.
Should I mention now I'm certified? I took the online test. I mean, I have a little certification card. I can print it out.
As long as you print your IT test on the back.
Oh. Well, blank would be appropriate. So.
Anyway, so he was talking about how intumescent paint is like maple syrup. So is that sprayer that you have extra like gusto?
It's really strong. Yep. It will basically spray. You could probably run drywall like through it. It's crazy.
Okay.
So that gun, I can't remember what the pressure gets to, but it's like if I put my hand in the way of the gun, it would shoot paint in my hand.
Oh wow.
I mean, it's an airless sprayer, but it's able to pump this up high enough to shoot it.
And airless meaning you don't look at the compressor.
There's no air compressor. So that's what's good with it is it doesn't have a lot of overspray because there is no air. It's just literally shooting paint.
Well, it's just like, yeah,
So just launches paint out. Yeah. But yeah, the danger is that if you put anything in the way that you don't want paint shot through, it will shoot paint through anything soft. It's like it's the easiest way to think of it. It's a midline between our water jet cutter and like a pressure washer.
Yeah.
It's like between pressure washer and water jet, like force wise. So, but yeah, it directly siphons up this paint. This paint is like molasses.
Yeah.
So you whip this stuff up into a slurry, and you dip the paint gun in there. And I had asked Jim to come and lend a hand to be there in case something didn't work. Because the issue is like, once you crack open the barrel of this stuff, that's $460 in paint for 5 gallons. This gun can shoot a gallon a minute. So if I ran the thing, we're shooting out $100 a minute. And so every second that gun's shooting, you're shooting money.
So do you keep a 5-gallon bucket of maple syrup next to it? So
Yes,
spray it?
swap out. No, that's the other problem is there's no test. Like I've never run that gun. I bought it on Craigslist. The guy told me that it worked fine.
Yeah.
It turned out to work fine as advertised, but it's kind of interesting. The interesting part of that airless paint gun is I always kind of wanted to do screen printing, but with screen printing you need a pressure washer to wash out. But pressure washers have the same problem. Like they're too big and they can hose water everywhere. What's actually cool is that we can get an airless painter that's not quite as crazy as that one, but you actually use it as a pressure washer, but it's variable pressure.
Okay.
So you can actually turn up and down the pressure and hose out like a screen, and you wouldn't make water everywhere. Plus, you can control the. No, I'm not taking comments from a screen printer. Let me guess: a fine bristle brush and some water, and that's
I was just gonna say, if you're exposing a screen properly, you should be able to blast it with pretty much anything.
okay. That's washed out.
But if you're at sector, you're not.
Yeah, I was gonna say, what happens when you overrun it? It's sticky. So this was out in the parking lot. This is a blob of intumescent coating that came out while I was cleaning. And I got you a video, I know. You guys want to see it?
Oh, is this wet?
No, this is basement fine. It's definitely wetter than it is back there. But it's not like you can see that it builds, and then the fact that that really bright. The really bright orange is what it's supposed to be doing is absorbing heat and then rejecting it. So the fact that you're getting that super, it's literally intumescence, the really bright white hot color, is it radiating out, taking off the energy that's being brought into it.
Got the same result from Marshall.
Yeah, pretty
But
much.
it doesn't look like it's hot fire.
It will not burn, no.
Yeah.
And yeah, the thing is this is backed against gravel. So the back is sinking into essentially an infinite heat reservoir. So that's why it's not building very much because it's against a thing that's infinitely cold. So the propane torch is nuking the crap out of the top, but then the bottom's staying cool, and so it's not building. But if you look at the pictures of when they do this on a piece of steel, it builds like a 2-inch thick coat. It'll continue to grow. So this is not growing very much because it's against the wrong server. You would never use it in this circumstance, but.
So, I mean, I've done it too, cardboard, and it is somewhat fragile.
Oh, yeah, it only builds once and it's dead.
No, but I guess I'm thinking of, the whole idea of this fire rating, that not only do the fire getting through, but the firefighter blasting through after.
Yeah, there's a hose test.
So I'm
Yeah.
curious how that.
Yeah, I don't know. This stuff was pretty solid. But yeah, I mean, I've still got a bunch of it if you want to play around with it. And Mark successfully avoided painting the intumescent coating, but Mark did help me. So the other thing to talk about is before you put this stuff up, this is water-based paint. It's going on a steel beam that's unpainted or could be unpainted. If you spray this on a regular steel beam and you didn't put a primer coat down, it would flake and fall off. That's one of the important things is this, as they often say in UL Fireland, it's part of a system. It's not a product. It's not an individual product. So like just applying this to something doesn't confer a rating. You've got to have the right shape steel, like the right dimensions of material or the right base material. Then you have to have the right primer. Then you have to have the right thickness of this material applied to it in the correct manner. So Sean was trying to get me to roll it on, and it says right in the manual, do not roll the paint on. Sean's over there, you can roll that stuff on. So you can brush paint it and you can spray it, but you can't. But if we brush painted this, it would have been 15 coats, which Adam's also well versed in.
Well, the stuff we used was like, it almost was like shot.
That's
That kind of a thing.
it's like milky, it's like maple syrup meets chalk. It's real,
Yeah, the stuff we had like pink colored and horrible. Like,
they had
That's horrible.
install some wood in a commercial site that needed to be coated.
So post fire, do they scrape it off and do it again?
So yeah, if this was in a fire, you'd scrape off this stuff and then you'd spray it again. And that's part of the official like process. So anyway, other paint questions.
You said you need 6 inch fill.
Total thickness, yep,
It's 3 coats
at 30.
and 30 dry 20.
It dries out each coat to 20.
So as long as you were measuring 30 times.
Yep.
Then
In theory, it's
dry
good.
20.
Yeah, otherwise you can use a dry film thickness gauge, which uses the magnetic strength effectively of the steel that's below you. But in order to do that, you have to pre-measure the primer thickness. And if the primer thickness is in a consistent thickness, then you have no way of evaluating what the thickness of your material was. So, like conceptually speaking, you'd have to measure the dry film thickness of the primer, record that at consistent locations. Then you'd have to spray this on, and you have to remeasure the dry film thickness and subtract off the primer coating thickness in order to get a true build thickness. So measuring 3 coats at 30 thou is honestly probably just as good as it is to try and keep track of the location that you're measuring. But it is interesting. If you look back at the stair, it's got huge ripple effects whenever it's blocked. It's like there's a pipe that I was spraying around for the beam back there, and where the pipe was deflecting the stream, it like quadrupled the coating. So it's hard to spray around objects in short. But it's looking at what I sprayed, looking at pictures online, it basically did what is pretty standard to expect, which is you get ripples wherever there's something other than that. You get a big hole. It was very interesting to use the airless painter because you could move a ton of material really fast. Onwards to the next bit of fun. So the other entertaining thing we've been doing is blowing installation. This is Jim modeling how to install insulation, put insulation into the machine. So this blue thing here is an insulation chopper. Essentially, it takes these square bales, shreds it up, and then there's blowers in the bottom that blow the insulation out through this tube, and then it gets installed on the wall. Scott and his son Luke built this thing. My understanding is it's the only thing that got Luke into college, so he's very appreciative.
You used it on 2 essays at least so far.
This is what you're supposed to wear. So this is Tom modeling a nice bunny suit when we were insulating the other day, which is how to not get coated, as you'll see later. And then essentially we had this thing set up outside to try and keep the overflowing insulation outdoors rather than getting it everywhere.
Are those auxiliary fans you added later?
Those are, no, I made a manifold so that you could add together additional fans. So manifolds at the bottom, and then there's 2 fans going in, but you can have more or less if we weren't sure how much we were going to need. And those are essentially vacuum cleaner holders. It's a dog dryer, but 2 vacuum cleaner holders in series to get double the pressure. From Casey, just. So you can, there's 2 in series, and then in parallel sets in series. 4 blowers total, 2 series, parallel sets. And so you can see the shredder is taking the insulation and then curing it a little paint comes back to the wall. Then upstairs, this is what it looks like up here. Goes up stalling. So there's the insulation rocketing with the pipe. And then it ends up getting sprayed mostly into the wall, some of it everywhere else. This is Mark modeling proper protective equipment. Yeah, do it during the humid summer and you don't get shocked at all. So Davey was asking about what happens when you run it. When we run it during the winter, you get tased constantly because it's moving all that mass, generating a huge static charge. So you literally get zapped like this. You just get nailed. Yeah. So Jim and I were running it over the winter inside, and it was not fun. You just get hammered. So then you end up. What we had to do is we were blowing in behind drywall, and then using a thermal camera to evaluate whether or not we filled the walls. And so I had to drill a whole crap load of holes through the wall, fill them up with drywall, and then pass it. So, any cellulose pulling insulation projects? Yes, it's
So when you retrofit an old house, I would ever do that.
We know.
You do it from the outside?
yeah. So they would normally drill a hole through the outside. You'll either pull siding off, or you just go through the wood siding, and then yeah, you'd blow in and you'd fill up the wall cavity, and that'd be a loose pack. What Sean's trying to get us to do is a dense pack. So you can just blow in loose cellulose and it will fill.
No, it's basically it is a dense pack, and it really does take that neck down.
Okay.
That especially to the
Yeah.
in theory it should. Yeah, I mean in theory it's you always want to neck it down pre-compressing.
I hate to say it, but the slumlord house that I lived in when they did this, they just stuck the thing outside the wall and wait till it filled up.
So you can do what Sean was doing in terms of, you can push that.
Feed the hose down.
Yeah. They're drilled like a.
And often they'll be lazy and not do things like also drill a hole in each window.
Right.
But they only have a kind of buy a house and find out afterwards that underneath every single window, just like empty cavities, they're too lazy to do.
That'd be Jim's house. All right. So the next step is doing what's called a California patch. So you're taking a hole saw and a drill press, and you're cutting through the two layers, like the back paper of the drywall and the core of the drywall, and then leaving the front paper of the drywall intact. And so essentially, this thing's, I don't have a picture of it, but it's like a circle of drywall with a circle of paper stuck to the front. So you take that and you mud it into the wall. So that's what I was doing here, is sticking these patches. So you see there's holes all over the place to get patched. And then the upper left are ones that I didn't do yet. And then once you're done with that, then you got to tape all the seams, which I talked about last month, the taping machine. And then you tape the rest of the seams and you find the holes that you missed the first time. Then the thing I wanted to mention tonight is sort of like what the next step is. So normally if you've done drywall before, you get out this stuff. Dave, you've been replaced. You get out a pan and your knives, right? And
If you're a real man, that's what you do.
apparently I'm not. I'm totally comfortable with. So you get out your mud and your knives and your mud pan, and you mix up your mud and you stick it in there. And then you go spend hours daily adding mud. Or you do a bad job and you slam a ton of mud on there and you spend hours sanding. And there's like no way to avoid spending hours. You either put too little on and then you put more on.
You got the wrong people.
Like a volunteer.
Where are you been at? Oh, that's right, working on your house. So I went ahead and took $900 of you all's money and bought these things. And so this thing is called a mud box. So as you might imagine, it gets full of mud, and the whole back lid is hinged. So this thing moves in and out. So it's sort of like an accordion. So you put mud in here, and then as you push the handle into the wall, it squeezes the mud out this side. Then there's a squeegee blade made out of carbide on the back, and then in this case a roller. And this roller is really important because it helps with screwed up walls. And we have a lot of screwed up walls, so it's really handy to let this thing auto balance. And what it does then is, in this picture, it's feathered at the edges and then it feathered in the center, because in this case, this wall is bowed outwards as a smidgy bit. And so it's finding the center tape line that's built up, and then it's hitting the outside edges. And the amount of taper that you get is adjustable here. So I have it set to have quite a bit of build, because I don't really care how much drywall I use. I just want it to fill up and coat it. But you can narrow it down and make it thinner coat. But long story short, this thing, you drag along the wall and it leaves behind like a snail's trail of mud. And you do that once and it's got a whole bunch of pit marks all over, and then you do it again and it fills all those in, and you do it again, it fills them in. And that's all like as it's wet. So like you run one coat and it sort of half-ass sticks. And then you squeeze it again and you run it again and it fills it in where the hole, like the pits were. And then you squeeze against the wall and you pull it again, and then it'll give you like a smooth finish.
All in one go.
In one
How
go.
many coats?
3 goes.
3 pulls, but 1 coat.
Oh, you're at finished quality at that?
That's, well, you can go up and look at it. I haven't sanded anything up there.
So you do 3 coats and you're done.
Well, this is a 10-inch wide box. So you tape it just like normal. Then you run your 10-inch box, which is what's like, you can go upstairs and look at it. And it's, I don't know, it depends on what you want.
You could basically prime it.
I think you could feather the edges where it's overbuilt in a couple spots, and then you could probably roll a thick nap roller and it'd be fine.
You have a tapered rocket.
I have a taping machine to
Yeah.
start with. Yep.
Which is basically a box of mud tape.
Box them out of tape. Yep, so it's tape expensive.
And this thing in your hand is $900, or all those?
No,
together?
everything combined.
Yeah.
So I have, this thing's a nail spotter. Jim put a handle on for us, which is nice. So it's a miniature version. So it's a teeny little box. Same exact thing as the big box. This is a 10-inch box, and then I have over in the box a 12-inch box that I have not used yet.
What is that small one?
Nail spotter, does all the nails. The nail for sure.
You really need one for that?
Oh, well, be lazy of you.
You gotta get over it.
That just seems way more complicated than just like filling a screw hole. Like,
Well, there's thousands of screw holes.
Yeah, when there's a lot of
yeah,
screw
but
holes.
when it takes like a fraction of a second,
Well, but you gotta go, usually you gotta go 2 directions, and then usually you gotta come back and read
yeah,
it.
right?
Yeah, and then you gotta come back though and do it again.
You do, all your screws are lined up on a stud, you go.
I hear a
up,
volunteer.
and you
I
go
was
down.
gonna say, you can do one wall, I'll do another wall, we'll see who comes out.
Contest.
It could be good.
This is a makerspace, Adam. We don't use the easy way. We use the technology.
Yes, we use the hardest way possible.
Didn't work out for John Henry.
So.
Well, it look good in there.
So at any rate,
But he did win.
you still gotta do around the outlets. Cause you can't do that with any fancy tool.
Unless you don't put the outlets in.
Yeah, unless you don't do the outlets first, then you can probably do that. So the other important component that I have failed to mention thus far is you gotta have one of these.
Oh, that's
White pumper.
This is your pump. So this is your mud pump, and it's actually I'm actually impressed with the engineering of this thing, because you can pop these 2 clamps off, you pull a pin, pull the top 2 pins, and the entire thing falls apart. You can get to every single internal surface, clean everything, and you don't need any tools at all.
And it's easy to put back together once you have a pile apart.
Yep, then you stuff it back together again. And they don't include a manual or pictures or anything. So when I got this, I was like, what are the odds I'm going to be able to take this apart and put it back together again? And sure enough, it's made to be.
Now, that's hooked on your 5-gallon bucket when you're using it?
Yeah, it goes in the 5-gallon bucket.
Yeah.
So you end up mixing up however much mud you want in your bucket, and then you take your pump, and it slides in, and then the foot thing on the outside you stand on. So when you're pumping, because again the mud's thick, so you got to be able to pump against yourself. And then there's this attachment for filling these boxes. And then what I didn't buy is the bazooka. There's a big ass tube thing that's supposed to put out paper for you, the taping thing. That is like $800, and I was like, bridge too far. I'm not spending $1,600 to be lazy under drywall.
So then it's got like a neck, like a ribbon type that, you have to go in that crack.
Yeah, so this has got a little adapter. And then for the bazooka they have, it's like an F-shaped curve to fill the bottom of the bazooka up. We don't have that because I don't have a bazooka. But
So you can't open the mud box and dump it in, you have to.
no, it turns out I tried doing that. Because I was like, I do not want to clean this stupid thing out when I'm trying to figure out how to use these things. And so my first approach was pop open the back of the mud box, which comes apart for cleaning, try to sling enough mud in there to do something, and then stick it all back together again. I tried like putty knifing mud into the face of it. Anyway, the other fun bit is it doesn't work if you don't have it full, because you can't squeeze hard enough to actually get anything out. Adam, I'm not taking any more conjecture from you.
All I wanted to say is that I'm glad that the place is getting mudded and taped.
Positive comment? What is this?
So, you know, there's window trim over there even, I mean.
That's all shot. Don't give me that.
I gave up on this place a year and a half
Oh
ago.
my God.
So, are you gonna put knockdown up, or this is paint ready?
This is, the idea is we haven't textured any of the walls anywhere. So I don't own a texture gun. If I had a texture gun, maybe.
You didn't own a bunch of those either. What is, where's the drywall money?
Yeah, I thought about it.
Let's get a high school kid class together, just whip it.
Mix it up a little bit.
That's gonna be the smoothest wall of the whole place up there.
It's probably gonna be a smooth wall. The reason that I'm trying to do the wall decentness is practice for the apartment where I should not screw it all up, but you know, no guarantees. That's why Adam isn't gonna help, because I mean, you know, he'll be
Practice
smoke break
procrastination.
halfway through.
I've been the only one trying to get this apartment to look halfway decent out of anything.
Any other questions?
Besides Heather,
Hey,
maybe.
we're not taking any comments. Any other questions? Anything? Anything at all? All right. No questions from the peanut gallery on the interwebs?
Hi, internet people.
Can the internet people see you when you're doing all?
Oh yes, the internet people get the same.
Can they see me?
They can see you, Adam. Yep.
Anyway,
Yeah, here's the
Like
bell.
they see
There
me,
you go.
there I am.
Have you guys ever done this before?
am I on camera? Ooh, hot mic, hot mic.
All right. Jim, you want to go next? We got are your files on here, or do I gotta?
I know I should. Okay.
Oh. Sure you want me to open it?
Well, at the end of that, yeah. One is the.
Oh,
Yeah.
Okay.
Does
I'm
have
at-
that way you can show you. Ooh, 15 slides. Tim's gonna be.
We'll hammer through already.
Where's the?
Yeah, I should do that. That's good. I have to go up and down there all the-
Oh, you didn't even. How are we supposed to?
Oh, it lost it when it, is this the,
That's open.
oh, that's weird. Yeah, I can go through the texture.
What do we
Go figure. Anyway, it doesn't matter. All right. So, last year I bought a electric bike off a guy on Craigslist.
Hang on, sorry, I'm getting an idiot. We gotta give it to the internet people.
Oh,
We're
hold on,
depriving
everyone.
the internet people. Yeah.
All right, everyone can see it? All right, so, I don't even remember what I was looking for, but I stumbled on it. The guy in Milwaukee was selling an electric bike for cheap because it wasn't working. And I talked Jeff into going down with a pickup truck. It actually cost almost as much in gas, I think, as the bike itself. So it was a bit of a gamble because I didn't know anything about it. It didn't work, and that was it, $100. So we went and picked it up, and then I started reading about it afterwards. I found out why it was so cheap. So the guy had gotten it used, obviously. The company was, I think, one of the first electric motorcycle manufacturers out there back before they probably should have been. So they started in 2006. US company, but they had a factory in Poland, I think probably just for cost to make bikes themselves. So they started in 2006, came out with an electric bike. It was nickel metal hydride batteries. I think I read that they spent like 100 or 150 million making this, and then went belly up 3 years later in 2009. Then they got bought out by their Chinese battery manufacturer. They went for a little while, and then they went belly up again in 2014, at which point they got bought out by the Polish company that was making the bikes for them. And they're still around, but they don't, in the interim, they lost like all their dealers and all the support and stuff went away for them. So the people that were enthusiastic and bought these that actually used them, a lot of places didn't. A lot of police departments, I guess, bought them because they were looking to reuse them in towns and stuff. The owners were incentivized because the batteries were dying really quick on them to hack the bikes and make them work. So there was hope there because they had already done all that, like back in 2014, 2015 timeframe. So the original bike, which is what I had, was originally a 125 volt nickel metal hydride pack. And they probably pushed it harder than it should have, which is why they all started failing. Because they pushed them for performance and range and charging. They were charging in like 2 hours. So they were probably too aggressive on all those things. So anyways, the backs were all failing on them. So people were looking for replacements and the company was out of business when they were. So some people way smarter than I am hacked the firmware on the charger and the controller to put lithium packs in them instead. So the popular one was a Nissan Leaf battery because it would fit. It was pretty straightforward. You can get them cheap, and a lot of people did those. The guy I bought it from had converted it in 2000, actually the year before 2020, with a Chevy Volt pack, which was a little bit weirder. But he got a Chevy Volt pack for it and converted it in 2021 and then let it sit over winter and didn't keep it charged. It slowly drained it too low and then the thing wouldn't charge anymore. So I wanted to erect the pack or 2 cells on it. So when I got it from him, he was just sick of it and wanted rid of it. So we went and picked it up. So we had managed with Eric's help to nurse the pack back, except for 2 cells were destroyed. So then I had a 34 volt or 34 cell pack instead of 36. But it was worth trying. So I wrote it all last summer into the fall on that, knowing the pack was probably had some other damage for, marginal cells in it as well. So I knew it was probably gonna have to fix something on it and replace it. And Eric came along again and helped out. He found a guy that was selling a whole Chevy Volt pack, which is kind of a thing, right? If even one cell goes bad in those packs, it's easier for people just to get rid of the whole pack rather than get it fixed, because Chevy won't support them anymore. So he found a pretty cheap whole Chevy pack that I could pick up and then repurpose just a portion of it for the bike. So I did that this spring, and I've been riding it since. And along the while, I kind of realized I didn't want to be like the guy that I bought it from and not have a BMS on it, because they serve important functions beyond just saving your battery. They might save your vehicle as well. So with that much energy in the pack, if it does go bad, bike converts into flames. So this guy actually posted, he stopped at a liquor store, I think it was, ran in for like a minute, came out and his bike was on fire. He wasn't charging it or anything, he just parked. So it burned up the bike and the 2 cars next to it as well. So a lot of energy in the pack and worth having a BMS. So a BMS is a battery management system. And all it does is monitor the individual cells in the pack. Sorry.
What's you're taking a Nissan Leaf pack or whatever?
Chevy Volt, the thing on the table.
Yeah, so a lot of folks use Nissan Leaf.
Isn't that like way higher voltage than
Yeah, so like a Nissan Leaf is a big battery, but it's made up of little sections.
so you're just taking a
If you take a portion of it, so like the Chevy Volt is probably a better example. That's a 360 volt battery. It's got 96 cells in it. I'm only using 36 of them, so I'm using a portion of it. So it has the same same capacity amp hour or endurance wise, just lower voltage. Yeah.
But the voltage is still on that one. What's your pack?
Yeah. So this winds up when it's fully charged, just under 150 volts.
It's not like it's a low voltage
Yeah.
pack. It's still got a lot of.
but he was saying 125, and I'm like, I figured most electric cars are probably more like 400.
Yeah, it depends. Like Chevy runs theirs, I think just under, it's like 380 maybe fully charged.
So you're just using part of it.
Yeah, so the original Chevy Volt battery was 96 cells. I'm using 36, so roughly a third of it. So I had some extras, some of which are for sale still. So the challenge then was, with a portion of the pack, can I reuse, or do I have to buy now BMS, which is the management system? So Chevy, in their car, to their credit, and every car manufacturer has a really good computer monitoring the cells to make sure that none of them get out of spec. And then if it does, that battery shortly winds up for sale on the used market, right? Because they also don't have a way to fix it. Usually it just says, no, you can't drive me anymore. And then people take it in and the place says, you need a new battery. That's sort of the unfortunate reality of the situation, right? Is even one cell goes bad in one of the packs of the 96, the car can't, it has no way to fix it. It just says, tough luck, this battery's bad. Now, in theory, you could go in and replace, but the way the GM builds them, you can't. Because for cheapness or cost of manufacturing, they make these monolithic units, which are not easily separated or recycled or anything else, right? Which is why you can get a whole Chevy battery with one bad cell in it, which is what this one was, for like less than a tenth, way less than a tenth of what a new one costs, right? So if you want to buy that whole battery new, somewhere I saw a receipt from somebody, it was $26,000 to buy a new battery for a car that's not even worth that, right? But you can pick up a bad pack with one bad cell for like $800. So it's a good deal if you want a portion of it. It's a bad deal if you haven't owned a Chevy Volt, because there's nothing in between that, because the going in and fixing it is just not something that they want to deal with.
There's still, I mean, that still seems like a lot of value for somebody. I mean, so there's enough people out there that are taking part in saving them.
Yeah. So fortunately for me, all that's been done, right? Chevy's been around since whatever, 2000s. And they've been around long enough, and people realize, hey, they're cheap for the capacity you get. So a lot of people are using it for like home solar and stuff. So a bunch of people have already hacked the battery and tried to figure out the BMS, because the next question is, you can get a cheap battery. People that buy cheap batteries are usually cheap when it comes to the BMS. So they're trying to figure out if they can use the BMS that's already there. The challenge for me was the original BMS is obviously designed to manage the whole battery. And can you pick up just a piece of it to manage just part of the battery? And that was sort of the challenge. Because the other alternative is like buy a good quality BMS. And those are, it'd probably be $300 or $400 for like a good quality one. And then there's cheap Chinese ones that are out there for $100 to a couple $100 for a 36S battery. So those are my options. The first I started with the, can I reuse the original one? It seemed like a nice, should be a well-made GM product, right? And then this is sort of the story of the challenge of doing that. I was incentivized by obviously not having the thing burn up. So fortunately, again, for me, a bunch of people have been messing with the GM Volt batteries for a while for solar applications and for electric vehicle conversions as well. Because it's a cheap battery people can get. People are trying to figure out if they can use it. And one of the things they want to know, unfortunately, well ahead of my asking the question, this was back in like 2019, people were already hacking the BMS to see if they could make it work. And somebody did. So there already is an existing hack out there to talk to the modules that are on the battery and get them to do the two things you want to do are monitor the voltage of the individual cells, and then make sure that they're all, when top balanced or at the top of their charge, make sure they're all very close to the same voltage. That's the thing that it does. So somebody had actually found the commands to do that. So I just had to figure out if I could do it with a partial pack, which meant using just a portion of that BMS system. And that was sort of an adventure, because I hadn't done anything with BMS batteries like this or the system that GM uses. So I found out, Chris has found a little bit about the CAN bus that was used to run this, which is a pretty standard thing in cars. I didn't know anything about it. And then the balancing commands had already been done, so there's a website out there with that information on it. And then the next one was figuring out, could I use it for 36 volts or 36 cells versus the full pack? And that wound up being a chore. And it was a chore for some interesting reasons. But I think it's going to be a workable model. And again, the whole way I was incentivized by not having my bike do this. So I started off with what I thought was a sensible start, since I already had a CAN bus to PC connector. I borrowed one of Eric EV Power's connectors. He had one of these since he had helped the guy with the bike before, and that used this little piece of hardware to do it. This USB to CAN bus, and the people that had hacked the system way back in 2014 used this software to build an interface that could talk to the bike when they were converting it from nickel metal hydride to lithium. Because what you had to do was go into the software for the charger and the controller and say, oh, it used to have these settings for minimum voltage, maximum voltage, charge rate, things like that. Fortunately, somebody had already done all that and wrote a little interface for this adapter to let you reprogram the bike to use different batteries. I needed it because in my case, the guy, when he converted it to 36. When 2 cells died, now it's a 34 volt pack, which meant that the upper and lower voltages changed. So I had to go in. So Eric was fortunate to have one of these. I borrowed it from him, then I bought one. I figured I'm gonna need it in the future. So I started with that. And I thought, oh, I've got a CAN bus thing. I'll use that. What I didn't realize was when I did put a gender adapter on there, because the bike was a female, so I did a female to male connector, that it also flipped the pins. So that was an adventure to figure out. Basically, I was trying to talk CAN over the wrong pins on the fucking plug. Should have realized it didn't. That was just one of the fun things. So then got the communications working between this PC app and the battery BMS controllers. And at this point, it's just a matter you send a command to them. Somebody else figured that all out. And it replies back with the voltage of the cells. It also replies back with the temperatures on some temperature sensors as well. This GM put a whole shitload of temperature sensors in the battery as well. So I was getting the answers back that I needed from that. Through all of it again, I was incentivized to make this work. Yeah, so this is
Park this next to the building?
And the tire's still doing fine, guys. All right.
well, this may have done also why Chris was motivated to get the paint up on the beams. Yeah, so I mean, there's a shitload of energy in those batteries. So when they go bad in a big way. You can actually see at some point the individuals. Yeah, so that's what's left of the B version of the bike, right? I mean, so the biggest headache was figuring out how to wire up a BMS that was originally intended for 96 cell groups to only be 36. And GM, for whatever engineering reason they had, they decided to break their pack up into 4 units that were managed, but not all the same. You wouldn't, not just like divide by 4. They broke them up into this unit. Unfortunately, none of those can add up to 36S, which was kind of a pain in the ass. And they also had the additional headache that you had to use the 18 on the end of the string, because that was what terminated the CAN bus. If you didn't use it, it wouldn't work. So I wound up, the smallest units I could do were a 24 and an 18, which were the 2 at the end of the string to the CAN bus, which unfortunately adds up to 42. So I knew I had to have 6 extra cells in there somewhere to make this thing work, because the guys that hacked it said that if you don't populate all of the basically inputs into the EMS unit, it will not work correctly and it'll drain your batteries. Apparently, that was just not an option. So I wound up actually having to add 6 cells to the pack to get it to the correct number or the minimum divisions that you could use for the BMS, which is kind of a pain. At first, I thought I could maybe just hook the 2 separate modules up at different points in the string and then share them between some, and that wound up making some sparks. But it, in a testimony to their engineering, it did not fry the modules, even though it sparked, I'm guessing, a significant amount of current through them. They must have been protected. So at this point, it looks like I'm going to have a little 6S pack on the side just to fill out the 18 cell section with 6 extra cells, and they won't do anything else other than just keep the EMS happy.
They won't, will they be part of your charge discharge cycle?
No, I'll probably just monitor them. So at this point, it's now that it works, I picked up a CAN bus for a Raspberry Pi. I'll just probably use that. It seems like it'll be easier way to interface. The code's already out there. The guys have written it to talk to them, and they've tested out the balancing. Basically, just says run very briefly, hook this up to a small resistor in the thing, and drain a little bit of current. And if you do that for long enough, which is hours, it'll bring them all to within 100 or 1,000 of each other.
So if anybody has had an electric car, plug it in with it, it's at like 30%, it'll go to like 70% really fast. But then, and the numbers are here, I'm putting here random, but then the 70 to like 99% will take forever. So that's why at like the supercharger station, because you bought a Tesla and you plug in the supercharger station, the supercharger quotes like, oh, from 30 to 70 or 80 or whatever percent it is, we can charge in this amount of time. But if you want to bring it up to 99%, it will take 6 hours. That's because it's balancing the last bits of the cell. So what happens is one cell will peak fast, and then the adjacent cell will be needing more current to fill it. And so now this BMS kicks in and it starts moving charge around to balance all these really closely. And turns out there's just no fast way to do that, to actually get accurate measurements. So that's why this balancer has a strategy of very small pulses of power taking out. But as a result, the balance might take 6 to 10 hours or something to get balanced. And the battery will continue to work on that as long as it's full to do that. Even while you're driving, you can try and balance it a little bit.
Yeah, so GM, I guess under load obviously gets more,
Yeah, it's way
because
harder.
once you start drawing from them, it becomes problematic. So the trick is that if you're trying to balance all these to within 100, less than 100th of a volt, you want the battery just to be sitting there. So typically at the end of a charge cycle, it'll run. And if you do this every day and you have a good pack, they shouldn't deviate much, so they shouldn't need much balancing. But if you keep them all like that, you can charge to a higher percentage of the battery. Now, in fact, GM picked a very conservative upper limit for charging the batteries and a very conservative limit for discharging. Again, with an eye towards longevity. So if you do that and you keep the cells together, right? So when I pulled these packs from Eric and checked all the voltages, there were, I think, 2 bad ones, but every single other one was as close as you could measure with the meter, right? Which was 100 volt. So that after, I think it was a 2011 battery. So after however many years have been used, say 9, 10 years, they were all within 100 volt through the BMS. Now the question is, if you didn't run a BMS, how quickly would they deviate, right? And that's going to be a function of, well, one is, were they damaged? So the pack I had, I knew it had been damaged. But if they're not damaged, how well do they stay in track? And this was a challenge, right? So a lot of the guys that are using solar charging storage systems said they've been running it for years and never seen a deviation. But they may have also been using them in way less challenging environment, right? I know when I ran the pack for a year without BMS on it, they started deviating more and more. But I also picked very conservative upper and lower limits on it because I knew the pack was already probably on its last legs. Right? But they did deviate over the year that I drove it. And the problem, of course, is how does the bike start on fire? Which is if when you charge it all the way up to the top, it's charging the whole pack to a voltage. Now, if some of those cells are low because they're getting out of sync with the others, that means others are being overcharged to make up for it, right? Because if you just say, oh, charge your pack to 144 volts, say, if one of them is a 10th low and this one's a 10th low, that's got to get made up by somewhere else because you're shooting for a total, right? And then when you discharge, you say discharge to this level. But again, if the low ones have higher internal resistances, which typically when they're going bad, they do, now they're going to start going low faster than the others. So now they're headed towards that low number you don't want to hit, right? And then when you go to charge, they're now even lower still. So again, you charge it all up. The upper ones hit, but you're still charging to a number, which means now you're overcharging more of these cells, and just to get this lower one up again even more. And if you repeat that often enough, eventually you're overcharging some of your cells, and that's where you start your battery on.
The fun thing with lithium chemistries is that they do a cell reversal. So what will happen is if you over discharge a cell, the cell actually reverses polarity. When that happens, the entire battery pack will dump all its power to one cell, which is bad. So then you get that.
And you wind up, yeah. And this was just, I mean, you got riding around town, pulled up and started on fire. So I think I have a model for hooking up a 42 cell pack, which will have a 6 cell sort of stub on it. It won't do anything other than I'll monitor it, and it'll fill the slots that need to get filled on the DIC. So now it picked up a CAN bus adapter for the Raspberry Pi, and that's the next step, running the code on there to get it going. So that'll be for next month, hopefully.
So you have to, if you're measuring the 10th of a volt, are you really super specific about what type of wire you're using, how long each wire lead is and all that stuff?
Well, they're going to 100.
Oh, but that's all inside, you're just
It's all
communicating.
Yeah,
That's
so
all inside the pack.
yeah, so key to this is the BMS is hooked with a very short lead directly to each of the cells, and none of the leads is hooked.
And this is the PCIM that you were?
Yeah.
Okay.
So the longest wire on any of those, and it is you're right, it is critical when you have a thin wire and a long distance, but the longest wire to any of those BCM modules is only about a foot to the cell. And that is critical, right? Because another thing is critical, right, is they're not under load, right? So they're just, you just charge them up and now it's going to start this process.
So how, what the part I'm missing here is if you're eyeballing these 6 phantom cells, but you're not charging them, they're gonna slowly discharge, so they're gonna stay charged just by the internal resistors in here that are like moving charges all around?
So he's gonna put on 6 stub cells
Yeah.
that have the primary package to discharge the charge routine.
Yeah.
So that stub pack doesn't get touched unless the voltage drops low enough that he has to charge.
But you would have to then take your little 6 stub cell out and.
Yeah, and this is yet, I got to get the rest of this working first. My general thought would be I'd have a little, because the 6S charger, I actually picked one up already. Those are cheap. Yeah. And I might just set that in the box because I got a lot of room in there. Yeah. And that then I could just hook up at some, you know, if I have to do that a couple times a year, that's fine. Because they should never get tapped. The question is, yeah, there is some baseline draw, which is what burned the guy that I got the bike from, right? Because he let it sit over winter. And he should have just had it on in charge, gone out and charged it in his garage a couple times, and he didn't. So once he let it get low enough, the charger wouldn't even start up anymore because it said, hey, it's below my minimum parameter, which is a safety thing, right? The pack's too low. In reality, he just let it sit too long. So if he'd gone in and done what I wound up doing, was just hook a charger up each cell to bring it up a little bit. It wound up taking a week to do, actually. But he said he let it sit for even more months. And by the time I got it, it took a week to bring all those cells back up to the minimum voltage that the charger would actually start up. But then it was fine. You know, I ran it for a year like that. But in the process, he took 2 of the cells negative, so they got trapped. So it got a little complicated. I had to like cut them out of the circuit, bridge over them, basically. Which meant I knew I had a kind of marginal battery, because when it took those low, the 2 next to them were already a little low. And you go, and they all were well below what they should have been maintained at. I think the minimum you should do is like 3.6 volts, and these are down to like low 2s, which is not a good thing. So I knew it was kind of a sketchy pack to begin with. And it was once one came along that was available, it was kind of a no-brainer to replace it. So the hope is to put a BMS on so it doesn't start on fire, and I can keep an eye on it then. Because mostly it's monitoring. I don't know practically if I'll be able to have, because a lot of them will have an interlock that says, you know, shut the bike down if any cell goes below this and that. I'd probably settle for just have pull up a screen where I can see the voltages after a charge cycle and see if any are starting to deviate.
The other relevance for everybody here is that this is what's inside of all your power tool packs, like your wonky batteries, your rivalry batteries, whatever. When you put those on the charger won't charge anymore because one of the cells was out of balance. And so then your charger will say, this pack's garbage, junk, we're not going to charge it anymore. In reality, you can pop open the charger, the battery, you can look at it and figure out which cells screwed up.
Just put it back in and it'll eventually start turning.
And you can occasionally use the one cell that's low and bring it back up again. But on the rivalry packs that I've taken apart that have been sitting for a long time, because eventually by the time somebody donates it here, it's been sitting for a year or something. The pattern's really consistent. There's a self-discharge on the BMS, and it ends up always spinning the same cells. So I don't know what they're doing, but it's always taxing at some of the cells, but not all of them. So like 3 of the cells will be fine, and 3 of them will be bad.
Yeah.
All right.
Any other questions? If not, Scott will have a real electronics project for that half-ass thing.
Yeah, it's good stuff.
Okay. So my name is Scott. I'm a member here. I'm not certified. But I'm certifiable. We're here tonight to talk about a project that we're doing with the furnace here at the space. So in the process of, we acquired this space, we converted it from a warehouse, uninsulated warehouse, single story to 2-story. well insulated workshop educational facility. We took out the ceiling gas heaters and we bought a 20-ton York HVAC unit. It's got 2 stages of cooling, 2 stages of heating, more than enough capacity to heat and cool this facility. And it's got a very sophisticated controller system. And so my presentation tonight is about our efforts to work toward getting more insight in that controller system, and then utilizing that controller system to run the heating and cooling more efficiently for our space, and giving us options like purge air, outside air, if we care to do that. So normally you can think of a furnace system, you know, there's a thermostat that's measuring temperature. If the temperature goes out of range, it'll send a command to heat or cool. And we're running, that's the way we're running our furnace right now. We've got a thermostat. Let me see if I can run the remote camera here to show you the control. I'm gonna stop the share and hopefully see this. Let me pin this up here for the local folks. So in our furnace, which is a York, which is a York unit, is one of these control boards, the made by Johnson Control, and it's again can run 2 stages of heating, 2 stages of cooling, has a microprocessor on there, and a number of other temperature sensor inputs and things like that. And then this other unit called economizer, which is a secondary controller that now is mandated to be installed in furnace system, which basically is a damper system to outside air, so that on nights like tonight's a perfect night. For an example of this, during the day we're going to want to cool this space. At night we've got free cooling outside if we care to have. So we could actually, with a schedule, an occupancy schedule that says, hey, we know we're going to be in this space during the day. We could run cool air in here, cool it to like -10 degrees of where our set point is overnight for free, basically just by pushing cold air in. We come in the morning, it's a little bit cool, but we get free cooling for our space, saved on the AC. So, so our unit has the intelligence to do that, and it's got its own internal temperature sensors and things like that, that you can run it basically independently of a thermostat. It will watch the air temperatures coming through it, and outside air. You can have an outside humidity sensor, an internal humidity sensor, so and it'll have all the schedules and things to run smart enough to run more efficiently than what we're running. So yeah, normally if you're an organization like ours, you would have a multi-$1,000 service contract with Johnson Control, some other local provider, which of course we are, you know, not going to do that. So we need to be able to understand this device to bend it to our will. And so Chris acquired this, what's on this board here, which is an exact match for the control board in our York unit. It's what they call a smart, it's a York Simplicity Smart Control Board and a matching economizer board. And my project was to wire up a virtual furnace so that we can program the unit, set temperatures on at different temperatures, and see what it does. So if you look on here, you'll see a number of potentiometers. Those are 10K ohm temperature sensor, fake temperature inputs for the furnace. There's a number of other connections on here you can see right now. It thinks it needs to be cooling. I could mess with the dials and have it think that it's going to do something else. There is a serial bus communication system, what they call a SA bus, a sensor actuator bus, which allows this smart unit to talk to this economizer and get the things like outside air temperature, outside air humidity. And then the economizer also has controls the damper, open and close a certain percent, depending on how much outside air you want to pull in versus how much you want to recirculate for free cooling and just fresh air in general. So we could even run like a CO2 sensor in here for monitoring air quality, and then bring in more outside air and heat it to cool it if you want to maintain a certain level of air quality. So, so this is working. I had to work my way through about 30 faults of like, oh, it doesn't, there's a fire alarm, doesn't not hooked up. So okay, I got to jumper that over. Oh, there's this temperature sensor is going bad, so then I got to pick a temperature sensor. And so just a little bit of a really a bad breadboarding project to get this thing running, and mostly just jumpers and potentiometers and switches. There eventually are a couple like 0 to 5 volt input signals, DC, 0 to 10 volt DC input signals. Most all of these HVAC boards run on like 24 volts AC. So, yeah, I think they get your work on that. So, so we want to be able to program and operate this thing. And I'll switch back now to the share the PC screen, because I'll talk a little bit about how these things are programmed and operated. So there's a protocol called BACnet, Building Automation and Control, and I'll just let me share the screen here for the most folks. This.
So the folks at home getting a weird.
Oh, far right, Scott. What's that?
All the way at the far right button. It'll pop it back.
Oh,
Yeah, where you were. Yep, that one.
oh, there we go. Okay. Yeah, so there's a protocol called BACnet, which was kind of an industry consortium standardized method of doing building control. Let's say that you had, a furnace and you had, 24 rooms with their own damper control and thermostats. They could all talk to each other over this system. You could have a centralized view of that, of what was going on. Let me just check chat here. All right. And so, and you can have different manufacturers' devices talking back. There's still some proprietary aspects to it. Yeah, there's various transports so there's BACnet protocol, which is, if you're familiar with like simple network monitoring protocol, SNMP, it's like you can query an ID and get a value back. So there's numeric IDs and string values, and there's different transports for the protocol, but ultimately the tools that monitor and enable like operational control of these things. And there's multi-$1,000 like full building or campus systems. Metasys is like the big jumps control, higher end one. There's like a Verisys mid-range one, and then there's what we're gonna see tonight, which is just a very simple web-based interface to this. I'll talk in BACnet. If you're familiar with old school serial ports on a PC, that was PIA-RS 232. What most of the industrial systems talk is a serial protocol called RS-45, which is a differential signal for a lot more noise resistance. So
Very similar to CAN.
yeah, it is. And so this smart furnace control board has a couple of different RS-45 buses on it. One is for the sensors and actuators to run the furnace. Another one is called the FC bus, the field control bus. So we can hook to that field control bus and then operate this furnace. We can interface with it programmatically. So let me switch back to remote cam here. And I'll show a little bit about that. So on this board is this is the field control bus here. It's a 3-wire differential signal with a common, and we've got a RS-485 to USB adapter that's going to the Linux PC here. And then on the Linux PC, let me
log in.
Oh, man, passwords going
Zoom.
on. At least we'll be safe.
I don't want to change that password, but.
So this Linux laptop is running a USB to RS-45 adapter, talking to the field control bus on the furnace. And I can run, I've got a Python library here that can read the present value and the description of supply air temperature. And so 29564 is the supply air temperature. And I can get the description and present value and a number of other things from that. So we could do basic operations there. We can write certain things also to it. There's a whole like number of open tools. There's yet another BACnet Explorer kind of tool. And we recently acquired this little device.
Scott uncheaped out and decided it was easier to buy a solution rather than.
Well, to learn. So this little device here is a Johnson Controls map gateway, which goes from an RS-45 bus and creates a Wi-Fi network with a little web app on it that actually manages. So 1 second, bear with me while I log in.
It's getting smarter.
Eric can take over from the car.
Yeah, no, so that's the feature of this.
Oh,
It's PASS.
So this is logging me in, and this one gateway device will support many, potentially many furnaces that we want, but I'm just going to go to our currently connected smart equipment 2-stage unit, and then it gives us this nice kind of, this is meant to run on a tablet. If you put a tablet to this web interface, there's a whole security model where you can have users versus administrators and things like that. And so then you can see here, it's giving us a little bit of the GUI cooling. It's occupied. Both stages of cooling are running at the set point 64. Space temperature is 90. So yeah, it's freaking out right now trying to get it cool. But again, that's just a matter of me dialing in. And so we can do commissioning, which is the process of kind of configuring this. We can set the number of stages. And we can do all sorts of things like we could then operate this thing to go into purge mode, which just vents outside as fast as it can. We can set occupancy or not. So like if we're actively managing the heat versus not, we can set schedules via this. And what we can do is then we've got Wireshark on here configured to capture the USB traffic so we can watch the values that get set when we run these things so that we ultimately don't have to rely on this map gateway device. We can program our own.
this is the thing that somebody did to get Jim's CAN bus messages.
Yeah, so
If you own the thing, why are you gonna try to redesign it? Are you trying to resell that thing? And save
Well,
your-
that little box is $1,500 if you have to buy one new.
yeah, we got one for like 300 something off eBay, but if it breaks, we're in a bit of trouble. I think we want to understand it ultimately, and we're gonna have another furnace upstairs as well. I don't know what that's gonna look like yet.
So eventually they would let any hacker on the internet turn the heat off because of.
Not on the internet.
Well, his apartment is gonna be a different system.
Interesting to know, this is very similar to IP traffic, but it's actually not on a network, it's on its own. Well, that,
Right now, we could actually put
Yeah,
this literally right on this also has an Ethernet jack, and you could run anybody that could log onto that wireless and have the admin password. Yes, could control a furnace. A couple of chat messages here, just check those.
quite useful.
Well, there you go. Okay. Yeah, so I guess it's been a few weeks of me hacking around with doing some breadboard wiring, learning a lot about BACnet and trying to find software off the Johnson Controls support site. So I had to upgrade the firmware on these. The economizer and the smart control board both have firmware that don't match, and we acquired them separately off of eBay, so they didn't match. So there was this process of getting those updated and consistent. There's a firmware which I just got today to upgrade the map gateway. It's basically something. It's running like a node-based JavaScript software stack for that web interface. So it's a little embedded thing that's got the RS-45 to probably USB and a Wi-Fi adapter and an Ethernet adapter, but ultimately it's a tech stack that is probably not readily hackable because even the firmware they gave me was an encrypted file. But I was hoping I could look at that, but not going to be easy to do that. But if we just want to have a tablet that shows the relevant temperatures and have a button to say, give me another hour of occupancy or run this in purge mode for 10 minutes, we can easily now figure out the commands we need to do in a basic user, probably a web-based user interface as well, but just run that off a touchscreen.
Did you get the codes figured out for the coin op machine?
Yeah,
We were gonna do the.
Well, that was my next question.
I think that's
Is there now a tiered membership program?
my zone in the core.
I was gonna say, you can do that like for each cubicle area, and is that precise?
No, well, we need lots of damper actually.
Exactly.
All right, so yeah, questions, thoughts?
So is this, I mean, is part of the hacking of this because you have to train your field person to deal with that?
So the reason, well, so I can give you the fact, like, why are we bothering with it? So the reason is the system can be super smart. It can understand what the outside air temperature is. It can also understand what the outside humidity is. Understand the inside air and humidity. And it can ratio like the economizer's set of louvers to allow it to draw on outside air if it's cool enough out. Or like Scott was saying, overnight, the thing can cool the building down on its own without having to have the windows open or whatever else. The problem is that all those features are locked inside the controller. And so unless we can talk to the controller, we can't use any of those. So it's like buying a Ferrari and then having to like stop and go button, but then it only gives you 10% of the stop and go.
Well, that's what I'm asking, is that typically like the user manual, like this is an open source, it's not proprietary or stuff, and they only normally do that.
The BACnet commands are open, given by them.
Okay.
So like you can access all the BACnet stuff. The only proprietary thing is the furnace controller itself, and then this map gateway. But you don't have to have a map gateway in order to talk to it. It just made it way easier.
Literally, we're running a Python open source module to talk the same command. It's just knowing those commands. And to be fair, there is kind of technical documentation on all of the available 300 set points for this unit, but it's not exactly explained in layman's terms to say, oh, if you wanted to do this, you need to set these 25 complementary settings to be in this configuration, and then you'll get what you want. So we want to be able to play with that without doing something bad to the actual furnace or running, overheating this place or whatever. So that this serves kind of two purposes: just figure that stuff out. Like, and there's probably members of the community that are Johnson Controls experts in this stuff that could be would be able to really readily answer and say, oh yeah, you do this, you do this, you do this, you do this, and you'll get what the behavior. But we're working on it.
What's a ballpark, like if you lock everything down, like everything, what's a ballpark estimation how much you'll save over a year, like percentage? Is there like what you manage, highly manage versus no?
So we're kind of an exception case because we have windows that open. So like right now we're running pre-cooled. I open up the windows, the user hasn't been on a month or whatever. But the ability for it to do some of that is important. So if you had a sealed up building and your only access to the outside air was that unit, then all of a sudden this becomes really critical. But the other rationale for this is like over the winter, when COVID kicks our ass again this winter, which we're heading towards, we're going into winter with the highest case counts we've ever had. Anyway, that aside, the idea then is we can open up the economizer, which normally would close itself down, right? And we can allow additional fresh air in at the behest of additional cost heating it, but it'll allow us to increase the air turnover, which we couldn't do last winter. Because another reason for trying to get this figured out is that we can open up the economizer and say, no, we want 50% fresh air. And we don't care if we have to pay extra to heat it. We want more air. So that'll allow air turnover without making the building cold. Because the solution last winter was like crack the windows, but then it gets cold. So, Mr. Adam?
So are you like violating some kind of laws here? If this economizers like
Something you don't
that
say out
has
loud.
to be installed?
No, the economizer came with it. But the funny bit is if you
So
run,
then, well, I think you said it was like a required thing.
there's a required air turnover, and it's required by law to have an economizer, but it's not.
Well, you
required
can
to
do
use
whatever
the
you want
economizer.
with
Oh, of course. No, this is a dumb exception.
Yeah.
The furnace has to be supplied with an economizer, but you don't actually have to.
Because you have to do this to be able to use.
Well, that's
Right, the vast majority of these units are run with a dumb thermostat, and that's not gonna kick the economizer into it. So, yeah, it's sort of this ridiculous situation.
So in like 6 years, when all this runs and everything's good, we've got a tablet, you can push the button and make everything more like that.
And the coin out button.
And the coin out button, can we repurpose this hardware in front of you to manage like window shading and other things?
Yeah, that was the other rationale for buying a spare of all this stuff. Is technically it's just I/O.
Yeah.
So like this controller doesn't know what it's controlling. It's got 4 relays, and technically 2 of those relays are paired, right? So they're tiered. So like you go stage 1, stage 2 heating, but there's a bunch of other I/O. There's a VFD control for fan speed. There's all sorts of stuff. So the idea of the system is that this would be on a BACnet network in our building, which could be through these map gateways, or it could be a separate network. And that network then would network all the devices together, and then you can have them work together to do whatever. you
Well,
want.
I guess my specific question was more of, does this firmware and technology understand like window shades and south-facing building and shit like that?
No, that's what the
doesn't
controller is
know. This is mainly for furnace. So it's basically a 2 or 4 stage furnace.
Okay.
But
But
if
we
you
have some
wanted
other
to-
server saying like, okay, we can close these 5 windows here and open up these windows. Put these
Yeah.
things down and do this shit.
And that's where you're getting in. So Scott's got this YAVE is what it's called. So you got another BACnet Explorer. That's allowed to send messages and receive messages, or people do just like what Jim's got, where you got a Raspberry Pi to make it a network. So the idea is that Raspberry Pi then would control the furnace, and it would control the window shades, and it would control the lighting or the exhaust fan or whatever you wanted to do. And so you could tie in and integrate all these things together that work together. Part of it too is to monitor occupancy. So we actually took out a ton of occupancy sensors from the city building
Oh,
that
sure.
we haven't done anything with. But you could put those up in the space and you know whether there's someone here or not.
And those are all RS-485.
Those are wire relays, but you can tie them
Oh,
into
okay.
the controller. And the other thing you can do is you go on eBay and you can buy $450 CO2 sensors for $15. So if you wire this into the return air ductwork, you can monitor CO2 presence. And so you can see if there's anyone here via the gas that we're seeing.
Can you just run a COVID sensor through there?
No COVID sensors available.
That's in the back.
So would you, Chris, would you use those CO2 sensors to in liquid with the economizer to provide that? So you could sense, hey, there's certain parts we're going to get to. That means more people are in the building, let's run more.
Yeah, so the economizer has that built in as a thing called indoor air quality. And the indoor air quality sensor is a 0 to 10 volt. In this case, the CO2 sensor is calibrated to match that and able to be recalibrated. So you can change the jumper and change what your indoor air quality threshold is. But yeah, the idea is if you had a super tight building and you had a ton of people in it, and that economizer detected, hey, our CO2 level is climbing, it would automatically, and if this is all built in, it'll automatically open the economizer and say, nope, we want more pressure. We don't care if it's -30 out. We need the air to dilute the CO2 that's in the building. So that's built in. That's already a thing that it does. If it has a CO2 sensor, but without the parameter that Scott's talking about, if you don't go into and tell this thing, hey, you have a CO2 sensor, pay attention to this, it won't do anything. We can install a CO2 sensor, but it won't do anything else you can program.
And since we have all this automation, a really tight building, and a restaurant grade exhaust fan, will we be able to time makeup air into this whole scheme?
You can also do that where you open up the economizer and allow additional air to be drawn in to make up for losses. Or like,
Is that like a pressure differential, or would that be like there's a switch?
you can have both, but yeah, you typically just monitor pressure. So usually they run buildings as positive air. So they actually run the louvers open a lot more often. And they'll maintain the air in the building pressure. So you're going to office buildings sometimes and you're like have a hard time opening the door because the building's being run negative. So it's sucking the door shut.
Yeah.
And other times you go to a building, you like touch the door and it flies open in your face because the building may run positive. And so the building is supposed to be controlled to be positive, but it depends on a sensor, pressure sensor. That kind of thing. So that's another thing you can install. That would add to the cost because everything is a balance of comfort and cost, right? You have the most comfortable building in the world, it's going to cost a ton to run. You have the least comfortable building in the world, and depending on how you've got this thing set up, it might cost a lot more or a lot less to run.
My main goal is to have Chris be able to type vent core on his computer, and it'll actually like, vent.
There is a purge going built in, so when Jim's lithium ion batteries go down, we can try to draw the smoke out as best we can.
Lithium's expensive, you want to recycle.
So is there a reason to make a mock-up that's easier to play with?
Yeah. So
So I tried programming that, and it didn't do anything, and I got very nervous about what I could have possibly changed. So I was keeping track of parameters, but the point was I guessed 2 parameter values and I changed both of them, and I didn't get the desired outcome at all, nothing changed. And I went, okay, we have a black box that I'm poking 2 buttons, and neither of them are doing an intended outcome. We need to build a model because if you keep poking it, it's going to be bad.
when you're doing things like temperature sensors, well, setting up your edge, you're setting up the case that you want with the actual temperature sensors is a little bit tough. And so I just put LEDs on to say, oh, is the fan running? Is cooling stage 1, stage 2, heating stage 1, stage 2. You can see at a glance what it's doing, and then you can just set up your scenario. And there's, you have to wait because that thing doesn't want to cycle compressors frequently, but you let it wait, and then it'll go and do ostensibly what you want it to do. It's faulting right now, for instance, because it says I've been trying to cool for 30 minutes and the temperature isn't coming down, so there's something wrong with one of those compressors.
Clearly,
Your 90-degree supply air temperature is not getting any better. So yeah, it enables setting up those scenarios, and it just enables us to understand the unit a lot better as well. And as an aside, if that board or either one of those boards would ever go bad, we'd be able to readily by working through this, we understand the diagnostics a lot better about the sensor networks.
So is there active community hacking these, or just not a done thing in commercial property?
No, I haven't found any community that's hacking it. Like, you've got the HVAC, there's HVACtalk.com or whatever, I registered on that thing. And that's mainly like all the HVAC techs who are basically trying to struggle to understand what this thing is. And it's salty because it's not a pneumatic, control circuit. So the industry is slowly evolving for these smart controllers. There's a lot of resistance to going with the higher tech stuff. People hate when these things break, and unfortunately, they've had some bad batches of boards and stuff like that. So, it's like, oh, these things are crap, or but they're good for doing what they're intended to do. But you need to manage them as a microcontroller device, not as a relay.
Yeah, it's the same confluence of people who complain about cars being unfixable now. Oh, the cars are impossible. It's like, no, you can plug in a controller and you can ask the car what's wrong, and it tells you exactly what the part is. But all the old mechanics are like, well, there's no carburetor to tune, and I can't tune this thing anymore. It doesn't need to. But I think it's the same thing with this, because I've seen the same complaints of people like, oh, these new controllers suck. I want my, Whirlpool furnace from 1920, the same as my Whirlpool washer dryer that have not changed at all. And it's just not the way this stuff's gonna go.
I'm like, Unix, I don't.
Yeah.
I'm just seeing it like the centrally monitored security system and seeing it opening. Have like one guy in an office somewhere maintaining this, who knows the shit, doing it over the network.
Yeah. Right. No, and that's what a lot of the very sophisticated software stacks are enabling. Right now you have to pay a vendor a lot of money for the software to do that, but the networking infrastructure, the protocols are there within the devices to support that.
Yeah, but so somebody who's smart and figured it all out would have a really good business model.
Yeah.
Assuming you want your business on a network.
Well, every big office building has it's 10x times the complexity of what we've got, because they have multiple zone systems.
Oh, yeah, yeah, you know
All
what
that.
hopeless, right? And they had spent like 2 decades trying to get it dialed in. He still couldn't, like the heat and stuff. It was horrible. And all the companies they brought into it, you know, they're just, oh, we can add some more actuators to here and bigger fans here, but they could not get a decent system where everybody was happy, free and comfortable.
Yeah, so if you look at the number of large offices, I mean, this is just, it's a huge. All right, any other questions?
Great. Thank you, Mr. Scott. That's it. Anybody on the internet got anything to add? Otherwise, we're gonna cut you off. All right. Well, thanks everybody remotely.